Hi guys, I'm Suman and today we are going to discuss about the concept sockets. So firstly, what is a socket and why is it used? A socket allows communication between two different processes on the same time or different machines. To be more precise, it's a way to talk to other computers using standard Unix file descriptors. They exist on transport layer. They provide point-to-point and two-way communications between processes. Processes communicate only between sockets of same type that are in same address domain. You can send and receive things on socket. So next, socket address. Process to process delivery needs two identifiers. One is IP address and the other is port number at each end to make a connection. Socket address is a combination of IP address and port number. The socket address defines process uniquely. The widely used socket address domains are Unix domain and Internet domain. Unix domain contains two processes that share a common file system communicate with each other. Internet domain contains two processes running on any two hosts of internet which communicate with each other. So coming to next subheading, socket system calls in TCP. TCP does flow control and require three packets to set up socket connection before any user data can be sent. TCP handles reliability and congestion control. It also does error checking and error recovery. Error packets are retransmitted from the source to the destination. There are five system calls in TCP used to create a socket, identify the socket on the server, wait for the incoming connection on the client, connect to server socket, receive and send messages, and close the socket. Firstly, creating a socket. To do network I/O, the first thing a process must do is call the socket system call, specifying the type of communication protocol desired. The given below is the syntax. This call returns a socket descriptor that can be used later in the system calls or -1 on error. Let us talk about the arguments. Family. It specifies the protocol family and is one of the constants IPv4 protocol or IPv6 protocol. Type. It specifies the kind of socket needed. It takes values like sock stream, sock dgram. Protocol. The argument should be set to the specified protocol type given below or 0 to select the system's default for the given combination of family or type. Secondly, binding a stock. The bind system call assigns a name to an unnamed socket. This call returns 0 if successful binds to the address, otherwise it returns -1 on error. The first argument is the socket descriptor returned from socket system call. The second argument is a pointer to the protocol specific address, and third argument is the size of the address. Third, listening for connections. For listening on sockets for the connections, the listen system call is used. Here, S represents a stream socket descriptor and backlog represents the size of backlog queue. That is, the number of incoming requests that are waiting for the connections. Coming next to the accepting connections. The system call that is used for accepting socket connection is accept. S, it represents the socket descriptor. SADDR, it represents the pointer to the socket data structure. Socket ADDR, it refers to the address to which the socket is to be bound. SADDRLEN, it represents the size of the address. On success, the accept system call returns the socket descriptor that is available for the particular connection. On failure, it returns -1. Next, connection to sockets. The system call that is used for connection to the socket is connect. Here, S, it represents the stream socket descriptor. SRVR, it represents the pointer to the socket address data structure. It refers to the address to which the socket is to be bound. SADDRLEN, it represents the size of the address. Moving on to the concept socket system calls in UDP. In UDP, the client does not form a connection with the server like in TCP. Instead, just sends a datagram. Similarly, the server need not accept a connection and just waits for the datagram to arrive. Datagram upon arrival contains the address of sender which the sender uses to send data to the correct client. There are 5 system calls in UDP used to create the socket, identify the socket, on server, wait for the message, on client, send a message, send a response back to the client, close the socket. Firstly, creating socket. Creates an unbound socket to the specified domain, returns socket file descriptor. The given below is the syntax and the arguments are domain, type, protocol. Domain specifies the communication type of socket to be created, protocol to be used by socket. means use default protocol for the address family. Next, binding socket assigns address to the unbound socket. The arguments are sockfd, file descriptor of socket to be binded, addr, add structure in which address to be binded to is specified, address length, size of the address structure. Next, coming to sending message to socket. The given below is the syntax and the arguments are socket fd, that is file descriptor of socket, buf, application buffer containing the data to be sent, len, size of application buffer, flags, bitwise or the flags to modify socket behavior, destination address, structure containing address of destination, address length, size of the destination address structure. Next, receiving message from socket. The given below is the syntax and the arguments are socket fd, file descriptor of socket, buf, application buffer in which the received data, len, size of the buffer, application buffer, flags, bitwise or the flags to modify socket behavior, structure address, structure containing source address is returned, address length, variable in which size of the structure address is returned. Next, closing socket. The given below is the syntax and the arguments are fd, file descriptor. Moving on to the next concept, TCP server client implementation. This entire process can be broken down into the following steps: TCP server and TCP client. In TCP server, using create TCP socket. Using bind the socket to server address. Using listen, put the server socket in the passive mode where it waits for the client to approach the server to make a connection. Using accept, at this point connection is established between the client and the server and they are ready to transfer. If not, go to the step 3. TCP client. Create the TCP socket, connect newly created client socket to server. Next, coming to UDP server client implementation. This entire process is also broken down into the following steps: UDP server and UDP client. In UDP server, create UDP socket, blind the socket to server address. Next, wait until the datagram packet arrives from client. Next, process the datagram packet and send a reply to client. If not, go back to step 3. In UDP client, create a UDP socket, send message to server, wait until response from server is received, process reply and go back to step 2 if necessary, and close the socket descriptor and exit. So this was the concept on sockets. Hope you liked it. Thank you.